My name is King IV, and this is Introduction to IDEA Data Analysis by K-Squared. This is the 7th lesson in a series of 8 lesson sets on the topic of Introduction to IDEA. Today's files that we'll be using include the Customer Access Database and the Country Admissions Excel document, and they can be found on this Dropbox link, which I'll also be including in the description below. So let's get started. So now we have the two data sets, customer and country admission. So very useful. We'll be again going back to the analysis ribbon, and we'll be focusing on this explore menus, and we'll be covering 3 of the 4: gap detection, Benford's law, duplicate keys. So let's start with gap detection. So in this case, say for example, you expect that all customer numbers should be in order and shouldn't have any gaps, but you can clearly see that there are gaps, but we're going to identify where the gaps are. So we're going to click on gap detection. It's going to ask us fields to use. We're going to use customer number. Here's a sample record, the mass, so great. We're going to just look at the results. We're not going to create a new database. Press OK. And then you'll see the results where there are gaps. So you'll see that there's a gap between these two numbers. There's a gap here. These are all the gaps that exist within the data set. So you can see there's quite a few, and that's sort of expected. So we'll go back again to the customer database. We'll go back to the data, and you'll see the gap detection is right there. The next thing we're going to look for are duplicate keys. So there's 2 ways of approaching it. We can either create a new data set that excludes the duplicate keys, or we can use detection to identify where there are duplicate keys. So this is really useful to test the integrity of your database, especially your primary keys. So what we're going to do is we're going to first identify what the key is. We're going to use customer number. We're going to use a different key next time. So we'll say duplicate customer number. So in this case, there are no duplicates. So whenever the database is red, that means there's no records. Let's try a different one. So maybe we want to understand, are there potential duplicates that we should be looking for? So we're going to identify key, and we're going to use, say, last name and country. Press OK. And then we're going to go, we're going to call it duplicate last name country. And for example, we may want to know, are these people duplicates? We may do another level with their first name, or their status, or even their credit limit, and this just helps identify where we have multiple records that don't exist, that shouldn't exist. So interesting way of approaching that. The next thing we're going to cover is you can do an exclusion. So very similarly, it runs which records do you want, what fields do you want to match, where do you want to perform the exclusions. So we're not going to touch that. So we're going to go country admission, and we're going to go for Benford's law. And what Benford's law essentially does is that I'll include the link to like a Wikipedia page that describes Benford's law in more detail. But basically, it's a number detection pattern tool. So typically, when you think about a number distribution, you would think that the number 1 would occur just as likely as the number 9, because why not? Why would it occur any differently? But what you see in natural number distributions is that when you're evaluating the first digit or the first 2 digits, you'll see that 1 or 10, for example, would occur more likely than 9 or 99. But rather than going theory, let's look at the analysis. So what we're going to use is we're going to use Benford's law, and really what this helps us identify, is the data manufactured? Has there been manipulations to the data set? So we're going to be analyzing the field carbon, and we're going to be showing the boundaries, the mean absolute deviation. We're going to call this Benford's law, and we're just going to look for, let's say, for example, let's just look at the first two digits. So we're going to analyze the first digit in the carbon numbers and the first two digits, and we're going to export any suspicious data sets. So we're going to press OK. And what you'll see here is this red is the expected distribution. This purple is the upper bound, so we're applying a certain deviation, and then the lower bound. And this is the actual distribution. So you can see that it roughly follows, there are some deviations from the data set. So if this is a graphical form, maybe we want to actually look at the data distribution. So for example, the digit 1, we would expect it based off our population that it would occur 204.1 times. And the lower bound would be 191, the upper bound being 216. And you'll see the actual distribution is 246 with a variance of 41.9. And then you'll see the conformity based off of the mean absolute deviation. That is not in conformity. So again, we can go to the Benford's law first two digits and see the valuation. For example, we would expect that 10 would occur 28.06 times, and the actual result was 18. And then what we want to do is really want to focus in and hone in on this first two digits. So we can, for example, investigate these two records because they appear to be suspicious based off the digits and how often they occur. So really quick analysis, really great way to perform high-level assessment across the data. Obviously, this doesn't perform like any final conclusions, but it can help us narrow down and figure out, as part of your risk profiling, which records you should be investigating further in case they were manufactured. So again, that's exploring the data, really easy and useful tools to check data integrity, and as well use as a tool for your data profiling. So that's it for now. So if you have any questions or any other topics that you want me to cover, feel free to leave it in the comments below, and look forward to seeing you in the next lesson. Thank you and have a good day.